So in this short segment of lecture, I'm going to talk about how they actually look at the Milky Way. Remember, that's like in the nighttime sky, that's the disk. We're looking into the disk region of our galaxy, where we can look into that region using different wavelengths, or I should say gathering different wavelengths of light from the Milky Way, from our disk, and get different information about them. One of the things, as you see this, I'm going to kind of break it down. Each of these images is looking at the Milky Way, and kind of centered in these images then would be the heart of our galaxy, that supermassive black hole I've been talking about. So let's just kind of look at them individually. So for instance, the visible one, obviously, that's if the skies are nice and dark, that's kind of what you're going to see, or what we're going to see, the Milky Way. Now this would have to be taken throughout the year to kind of get an overall sense of that. Basically, kind of, it's a circle of that we would see from our vantage point. But so we do see these kind of dark regions, and remember, those are dark nebula I mentioned. And then if we switch from visible wavelengths to infrared, so that's getting a little bit longer. Check this out. Look how our supermassive black hole in the center kind of pops out. Okay. And my caption down here says that the reason we, well, it just notes that those longer wavelengths in infrared can get through those penetrating, those nebula, and visible light can't. Okay, so now notice I've added down here this is what the Milky Way galaxy, sorry, not Milky Way galaxy, this is what the Milky Way, or the disk of our galaxy, looks like in X-rays. So this is a little bit, this would be shorter than visible. This is what our galaxy looks like in radio at the 21 centimeter line. This is also radio, a little bit shorter wavelength, and it focuses, it sees the compound or the molecule carbon monoxide, and that's an indication for where stars are being formed, or potentially can be formed. Here we see another infrared. This would be a little bit longer infrared than the other one. Okay, and these at each wavelength, they tell us different things about the disk of our galaxy. Of course, the last one I didn't show yet is even shorter than X-rays. We'll be looking at the Milky Way, the disk of our galaxy, in gamma rays. And like this caption down here says, during during events like supernova, both 1A and 2, we get these gamma rays released. And so we definitely kind of, if this is the heart of our galaxy, you can kind of see closer to the heart of our galaxy, we have a lot of energetic events going on.